Hello, so this video is going to briefly go over vectors, how to represent them, and what unit vectors are. For the most part, this is something you should be familiar with already if you've taken any courses that have dabbled in vector calculus, linear algebra, or physics. But why are these important? It's because when we're talking about fields, whether they're electric fields or magnetic fields, they are vector elements. And that means they're characterized not only by a magnitude, but also a direction. So we're going to start our discussion with how to represent vectors, and then we'll move on to the position vector, which we'll be seeing a lot of throughout this course. So just to start off, a vector has both magnitude and direction. For any value that doesn't have a direction, we call them scalars. So to quickly recap, vectors have both magnitude and direction, while scalars only have magnitude. So in order to perform further analysis on this, why don't we just make a random vector A? So we're going to look at the unit vector in a bit, but let's say if we have a vector A, which is represented by the letter A with the arrow on top, its magnitude, which is a scalar quantity, is either represented by the absolute value of the vector or simply just the letter without the arrow. So if I have a vector and I can represent its magnitude as A or absolute value of vector A, then the only thing I have left is to figure out a way to represent direction. So we use the unit vector A hat to give us the direction of vector A. So a few important things about unit vectors. Unit vectors have a length of 1. And it's because that it has a length of 1 that it's called the unit vector, because of its unit length. And it's going to be in the same direction as its parent vector A. So how do we define the value of a unit vector? So we have A being equal to the vector itself. So A hat is equal to vector A divided by the magnitude of vector A. Or you can also rewrite this as vector A divided by A. So another really common vector that you'll see throughout this course is called the position vector R. So a common vector is called position vector R. And so remember how we used r as a distance between 2 points? Well, now we have a name for it. If there are 2 points, then the position vector r will have a magnitude of r in the direction defined by the unit vector r hat along the line connecting the 2 points. So let's quickly sketch this out again. We have our coordinate system, whatever it may be. And remember, there was some sort of physical object, which we represented as some blob. There was a point A over here, the origin was over here, and there was also a point P where we were making our observations from. So that means there's going to be different values for these lengths, connecting these points together. So if we had called this R from A to P, then we have a position vector in this direction called R hat. So we choose R to be our variable because we may want to move one point arbitrarily to different areas so that different observations can be made.